Hello, this is Chapter 20, Exercise 33. It says the IRS plans an SRS. The Internal Revenue Service plans to examine a simple random sample of individual federal uh, tax individual federal income tax returns from each state. One variable of interest is the proportion of returns claiming itemized deductions. The total number of tax returns in a state varies from more than 15 million in California to fewer than 250,000 in Wyoming. Okay, so let's look at this situation here. Well, let's read part A and then we'll do the situation here. It says, will the margin of error for estimating the population proportion change from state to state if the simple random sample of 2,000 tax returns is selected in each state? Explain your answer. All right, so here's what it looks like. So we have California, the IRS, they take a random sample of people's tax returns. So n equals 2,000 in part A. Um, and then the p hat is whatever it is. For example, if say 20% of the tax returns in California have itemized deductions, um, yeah, has itemized deductions, then your p hat would be zero point 0.2. So that we don't actually have to calculate here. Um, and then the z star, does it give us a confidence level here? No, they don't give us a confidence level either. All right, but that we don't need it. Now in Wyoming, in part A, sample size is still 2,000. All right. Um, so the formula here, p hat plus or minus z star times square root p hat 1 minus p hat over n. Okay, there's our formula. So question A is asking about the margin of error. So it says, will the margin of error for estimating the population portion change from state to state if a simple random sample of 2,000 is selected? All right. Um, so in general, the answer is no. The point of this question is the population size doesn't matter. Nowhere in this formula do you have to consider the population size. So population size doesn't matter. Whether you have 15 million or a quarter million, it doesn't matter. And the reason is it goes back to probability. If, for example, 20% of the population of California tax returns have itemized deductions, then you have a 20% chance of any individual tax return randomly selected to be in that sample. And then use that probability to come up with this formula right here. The same thing goes in Wyoming. If 20% of tax returns in Wyoming have itemized deductions, then even if it's out of 250,000, it's still a 20% chance. And so that same basic idea of probability is used for this formula right here. So all that matters is the sample size. Sample size matters. And in both cases, both are 2,000. All right, so the margins there will be approximately the same. Now, they might be a little bit different because you might have a different p hat. P hat in California maybe is 0.20, maybe in Wyoming, p hat might be maybe 0.25 or something. So you'll have slightly different margins vary based on different p hats, but it won't be all that much different probably. So the margins of error will be similar. Margins of error are are the same or close to the same. I'll just say similar. Okay, that's part A. Part B. Part B is, will the margin of error change from state to state if a simple random sample of 1% of all tax returns is selected in each state? Okay, well then it's going to matter a lot because California, what does it say? 15 million tax returns? 1% of 15 million, that's equal to, well, a trick for 1%, take off the last two zeros. So 1, 2, 3, 4 is a 15 with 4 zeros after it. So that means you have n equals 150,000. That's 1% of your population. So we have a huge sample size for California. Now, on the other hand, in Wyoming, 1% of all the tax returns. There's only 250,000 to begin with. So in that case, n would be, take off 2 zeros there, only 2,500. Okay, so in that case, the margins of error will be quite different. The margins of error are different. Quite different because n is so different, and n is a big player in those margins of error calculations. That's it.